Welcome back to the second lesson of week 7. In this lesson, we're going to talk about what it means to think concurrently. Thinking concurrently is one of the topics under computational thinking, and because it's a little bit more complex, I've picked it out as a lesson all on its own. In this lesson, we'll think about what concurrency is, the relationship between concurrency and dependency, and how concurrency is used inside the processor and in the work of a programming team. Concurrently simply means at the same time. We sometimes use the word parallel for two things going on at the same time, more than one task or process happening at the same time. That's all it means. And it's used in two completely different contexts in computer science. Concurrent processing goes on inside the workings of the computer, inside the processor, and it's also a tactic employed by programming teams when they're writing software. So the opposite of concurrency is linear dependency. And in a situation with linear dependency, the processes must occur one after the other. They can't happen at the same time. And that occurs when the result of one process is needed to start the next process. And when that's the case, you can't use concurrency. So this is probably the most common question they ask about concurrency in the exam. You can have concurrency or you can have dependency, but they kind of rule each other out. Processes can only be concurrent if they are independent, if one process does not need the result of the other process. Concurrent processing is quite common in modern computers. In a dual core or quad core computer, there are several processors linked together, and that means that the computer can do several different tasks concurrently, and that means that the work of the computer gets completed in less time. So if we opened up the processor, we'd see, well, this is obviously just a diagram, but a quad core CPU would have 4 cores inside the main processor, and each core can work independently. And so we have something like this going on where over time different tasks are being done, and they're sometimes called different threads. So different threads of the program will be going on at the same time inside the core. I should also say there's dual core, quad core, and nowadays we also get octo core, which, as the name implies, that's 8 cores. Now, concurrency is also used in a completely different way to represent how a team of programmers work. So this is a team of programmers, and when they're sitting down to do a task, they split the task up into subtasks. We already talked about this decomposition, and then each person in the team is given a different part of the task to do. And we've talked about how to make this work. For example, we set up common standards in advance so that the work, when it's done, can be fitted back together. And we've talked about methods for reducing risk, such as far as possible, eliminating the use of global variables. So we've talked about this before, many of the aspects of concurrent development, but just worth mentioning that this word concurrency can refer to this process as well. So in all of these examples that I've been talking about, the reason to do concurrency is to make something happen quicker. When we're writing the program, working as programmers, or when we're running the program inside the core of the computer. The main limitation on the use of concurrency is dependency. So if one programmer is waiting for another programmer to finish their work so that they can start, because for some reason they need their results, then we can't use concurrency because they're literally waiting. And the same thing happens inside a computer if one process is waiting for the result of another process. two other brief points I want to mention. If you want to use concurrency either with people or with computers, you need to prepare carefully and plan it and work out which parts of the task can be done concurrently. And then at the end, when the concurrent processing or concurrent programming is all done, you need to have some method for bringing together the results and combining them to give whatever outcomes you need. So to recap, you should know what concurrency and dependency mean, and you should be able to briefly explain how concurrency is used inside the processor and by a programming team. So concurrency is used a lot in games development. It's used by software teams as they write games, and it's used in the game itself as the computer runs a computer game. It's used in game development because computer game fans are always on the lookout for the next release of a game, and so programming teams want to produce the work as quickly as possible, and they use concurrency. They work as a team, and each member of the team will work on a different part of the game. Then when you've bought the game and you're playing the game, your game console or computer will use concurrent processing so that the game runs really fast and is very responsive. So the minute that you make an action in the game, it responds immediately to whatever you've done. And for that reason, it uses quad-core or octa-core processing. So if you are familiar with an action game, think of one scene and analyze it in terms of which parts of the development of that scene, the work of the processor, could be going on simultaneously. So if there's more than one monster in the scene, could the processing of those two monsters be going on in parallel, or is one dependent on the other? So you don't have to write a huge amount. You could include a screenshot from the game if you're capable of doing that on your system, and just pick out the times when you think parallel processing is happening during that game. Okay, so I'll see you in the next lesson. Bye for now.